Good afternoon. Welcome to a marvelous Math Monday. And we're going to go over the new Delta Math for those of you that want to work ahead this week. So here we go. I'll show you what I've got ready to do my math work. I've got myself some smoothie for brain energy, and I've got myself some company.
Hi there.
She's a little under the weather, but she's in great spirits.
Can I do one? Can I
And then I've got also some more company there. Hi, buddy.
do one?
Hi. They're both very good at math,
Yep.
and they're both going to help me count out my A's and B's and C's in this unit. So we're going to go through thing by thing. The other thing that I have available is I have some paper, but you get to see my paper. My paper's over here, you see, and I get to draw on it like this, like high class. All right. Now we're starting a new unit, and it's all about algebra. Algebra, we're going to see things like A plus B equals 3. We're going to see stuff like that, and you're like, wait, what? I'll tell you what. A and B, these numbers here, are just numbers we don't know yet. Okay? And I don't know what A and B are yet. No one knows. But I do know that I can work with this, right? Here are some things that I do know. I do know that A is the same thing as 3 minus B, because I could, if I wanted to, if this is 3, I could say subtract B from both sides. I don't know what number B is yet, but I do know that B minus B, if B is some number, then it minus itself is 0. So that would make an equation A equals 3 minus B. Okay, I can play around with these things in this way. Maybe I have something like A plus B equals 3, and then I tell you that A is equal to 1. Well, then we can just put it in there for A, and it's like this. It's our 1 plus some number. We don't know what that number is, but we know that 1 plus that number equals 3. What do you think that number is there?
2.
That would do it. Yeah, that's right. I told you that she's good at math. Yeah, so then we would know that B is equal to 2. Because we would look at it 1 plus something. Well, 1 plus 2 is 3. All right. We could also do it the slow way and say, well, we're going to subtract 1 from both sides. And so then we'll have 1 minus 1 is 0, B is B, and 3 minus 1 is 2. So that's how we would know B is 2 if A is 1. Okay, everyone, let's get started. So the first skill that we're going to be practicing is over here, combining like terms. And there's a guided version and a not guided version. I'll show you how to do the guided version. So we want to simplify this, and simplify this word means, I know this is math, eh? It's crazy. Simplify means that we want to write this in the simplest way possible. We're not finding an answer. We're just writing it in a simpler way. That's all you need to do. So one thing that I notice is that we've got negative 2 times some number squared minus 6 times that number cubed minus 2 times that number cubed plus 7 times a different number cubed. We have x's and y's here. Minus the number x plus 3 of the number x minus 7 times y to the 3. So what it wants us to do is click and drag the like terms. Okay, and now let's talk about what makes a like term. A like term, x, would be a like term with 2x. Okay, x, we can think of it as some distance on a number line. Let's say this is x, and then this would be 2x, like this. Okay, there's 1 plus 2x. So if we had something like x plus 2x, it would look like this. There is a line x plus another line x plus another line x. So that would be, you guessed it, 3x. Just what I just showed.
Excuse me, Daddy. Can you do a math one for me?
Yeah, I'm doing this one for you. But now if I've got like x squared plus 2x squared, and I have someone climbing on me, it makes the math harder. Plus, let's say that 3x from up there. If I have something like this, now let's draw this. X we decided was some distance, right? So I'm just going to move my face because I'm not doing any good down there. I'll move me up here. Okay. And
Can I do one? Can I do one?
Here's 3x, right? 1, 2, 3. It's some length. It's some distance. And so this is like a way that I could write 3x. And then x squareds, what would those be? Well, those would be, here is the distance, and then here's the distance as well. Okay, they're little squares.
You're really good, Daddy.
They're like I take that x and I have squared it. Okay, so there is x squared, x squared. This is the 2x
They
squared.
weren't going to do math for me.
This is math for you, Miles. Be more patient. So when I add these up, I can't add that to that. It's not like. It's not the same thing. So I just have to add them separately. So this equation up here, this expression, would be 3x squared, because I count them 1, 2, 3, plus 3x. All right. And later on, if someone tells me what x is, I could substitute it in here and calculate it. Let's say someone tells me, pick a number, Miles.
20.
Okay, if I know that x is equal to 20, okay, what I would do is I would substitute it in there for this x I don't know. So I would have 3 times 20 squared plus 3 times 20. Okay, now just substitute it in for x in both places, but here I have to square it. So this would then become bedmiss, so do the exponent first. 3 times 400 plus 3 times 20.
400?
Yeah, because you told me 20. 20 is a pretty big number. And it gets real big when I square it. Like that is to say, here is a square with side length 20.
400 is big.
So there it is. All right. And this would have area 400. Okay. Now, let's carry on. 3 times 400, 1200. Because 3 times 4 is 12. But this is not 4. It's 400. So it's 1200. Plus 3 times 20. Well, what's 3 times 20? Do you know?
I know.
3 20s?
I know. 325.
No. You got to count by 20 3 times.
20.
60. Everyone, 60.
Yeah.
So this is 1,260. Okay. When x is 20, this is equal to 1,260. But that's not what this is asking you to do. It's asking you to click and drag like terms onto each other to simplify fully. So let's drag the x's onto the other x's. Okay, and it says minus x plus 3x. So I think that if I have negative 1 apple, but then I add 3 apples, I would have 2 apples. So I have to put in negative 2x. So I just add these together. Negative x plus 3x is positive 2x. Almost got into trouble there. Try it. It's not simplified. Good. Okay, so that's that one simplified. Now this y cubed could be combined with this 7y cubed. So let's drag it onto it. Okay, I'm just dragging the like terms onto one another. And now I have minus y cubed plus 7y cubed. Well, that would be 6y cubed. Try it. Miles, please don't play with those. Those are not toys. We have to keep those clean. Those are the water bottles that feed our family. Well, they hydrate our family. Okay. Thank you, Miles. Now, no, that's fine. They can hear that. Now we're going to take this minus 2x and put it together with this minus 6x cubed. The minus 2x cubed and the minus 6x cubed will go together.
Another one, Daddy.
So this would add together to give us minus 8x cubed. In a minute, Miles, you can, but here, let me finish. I've now successfully combined all the like terms, and now I can submit my answer. And yeah, I want to submit that answer, that's fine. Hooray! Okay, so this is practice gathering the like terms. Now let's do one where we aren't guided, okay? We just have to combine like terms here. So with one like this, here are some strategies of how you can do these and avoid making errors, because we want to do these and be able to avoid errors. This is a kind of math procedure we're going to be using a lot in coming years, and you want to know how to collect your like terms. So here, first thing that I will do is I'm going to copy it down. I'm going to use black. Minus 5y cubed plus 3y cubed. I can see some y cubes there. Plus 5x cubed minus 3y cubed. Oh, I need to write this a little smaller, I guess. Okay, here we go. Minus 3y cubed plus x cubed minus 2y squared plus 3y squared. Is there something interesting in your belly?
Like I wanna.
No, not quite yet. So now I want to collect my like
What?
terms. So what I'm going to do is I've noticed we have y cubed. So I'm going to circle all of them in red. Okay, I'm going to use, oh, there's another y cubed there. Notice that I circle the minus as well. Okay, because that's part of this number 3. And just circle that and its sign. And those are all my y cubes. Now let's use green to circle my x cubeds. Now I have y squareds over here. So maybe I use blue and I'll circle those in blue. Okay. Now it's just up to me to write an equal sign here and collect them. So let's count our y cubes. Well, let's count the other ones first. X cubes. So I have 5 of them here and 1 of them there. That means I have 6 of them. And Mr. Jennings, you drew us pictures for the x squareds. What about an x cubed? Well, an x cubed would be like that. And I can't add cubes to lengths, and I can't add areas to lengths, and I can't add, they're not the same. So I only collect the ones that have the same base and the same exponent. I have to have same base and same exponents to be collected as like terms. Now let's do these blue ones. Negative 2y cubed, y squared, plus 3y squared is just 1. So it's plus y squared, just one of them. Because I had minus 2 and then I added 3. And now let's collect our ones in red. So this is minus 3y cubed. So it's plus 3y cubed minus 3y cubed. That would be 0. So I would only have minus 5y cubed. So let's type that in. I think it was, what was it, 5? No, 6x cubed. 6x cubed plus y squared minus 5y cubed. Hooray! Do you want to see another? Of course you do. Okay.
No.
You don't want to see another? You understand this one? Oh. Well, you've had a lot of TV time already, honey. No more TV. You need to watch. You need to do your math practices in a ratio of 3 to 2 with your TV time. So you owe me a lot of math practice. Now here, minus 2 plus 5x cubed plus 3y squared plus 4x cubed minus 7 plus 3 minus 5x cubed. Okay, get out your pens. Here is minus 2 minus 7 plus 3, okay? All of these are just numbers. We can combine them. They're like terms, okay? They're just numbers. They're constants. Okay, now let's get out our green pen. We've got x cubes. Oh, we've got x cubes there, and there, and there. Okay, so let's gather them up. 5 of them plus 4 of them would be 9 of them. Then subtract 5 of them would be 4 of them.
Daddy.
4x cubed. What, that one? That's 3y squared. So 3y squared is just going to hang out. It's just going to be there. Doesn't have to be combined with anything else because it doesn't have any like terms. And then we put together our numbers. Minus 2 minus 7 brings me to minus 9. Plus 3 brings me to minus 6. So that's what that's going to be. 4x squared, cubed, sorry, plus 3y squared minus 6. Hooray! Okay, so this is a big topic that we have for this this unit. Another big topic is the distributive property.
Can I make a video?
After I'm done my video. Okay, let's go.
You're a YouTuber.
Hardly. All right, so here we go. I'm going to take a drink of my smoothie. One moment. All right. If I have something in my teeth, it came from the smoothie. Okay, so distribute 2 by 5x plus 2. Okay, distribute. What does that mean? Are you looking to see if there's something in my teeth?
Yeah.
Let me suck my teeth to collect like terms. Should be better. Anyway, what are we looking at here? We are looking at a question like this. This one, it helps to think of Mario and Goombas.
Yay!
Okay, 2 multiplied by this bracket, 5x plus 2.
What is my pen?
Okay, so here we have 2 of this bracket. This is telling us to multiply this contents of this bracket by 2. So when I do that, I want to make sure that Mario here, this 2 is like Mario, and he jumps not only on the first Goomba, but also onto the second Goomba. He does like a double jump here. All right. So what that means is I want to multiply this whole bracket by 2. I have to multiply all the contents by 2. Okay, so this is equal to 2 times 5x plus 2 times 2. Okay. Now we keep going. This is 2 times 5x. That would be 10x. 2 times 5 is 10. And then we have an x that we're also going to multiply in there later. Plus 2 times 2. Okay, so that would be plus 4. All right. Now, some other things to think about with this whole Mario idea and the Goombas and things. And I'll show you a very common student error is to say, well, I'm going to multiply this 2 by everything in there. So I'm going to multiply it by the 5 and the x and the 2. Okay, this is a mistake right here. If you multiply this 2 times 5, Zara, can you hold it for a second? I don't want to talk over you. If you want to sing, go to the other room. So if I'm going to multiply this 2 by the 5, that's fine. That would be 2 times 5 is 10. And then I'm going to multiply it by the x. This is already joined together in multiplication. So if I multiply 2 times x, that would be 2x. And then 2x times 5 would be 10x. Okay, but I don't need to multiply it twice. I don't need to go 2 times x and 2 times 5 because this multiplication already happened. It's all joined together in multiplication. The only reason Mario needs to jump on several Goombas is because there's this addition here. So the addition does something that's called dividing this into 2 terms. This is term 1 and this is term 2. They're connected. Terms are connected by addition or subtraction, and terms are joined together, like the 5 and the x are joined into a single term by multiplication or division. Okay? So the 2 jumps on the 5x and then it jumps on the 2. That's what we've done here. And then we wrote that. So that is correct. 10x plus 4. All right, let's take a look at their explanation. Okay, so that they see it as 2 times 5x and 2 times 2, and they kind of float down into the new thing that we're going to generate. Okay, I prefer thinking about Mario and jumping on the 2 Goombas. Maybe this one is a Koopa. You know, it has like the turtle part and the shell part, and you just need to jump on the turtle part or the shell part, and that's enough. But the Goomba here, you just jump on it once. Okay, let's do some more of these. Next problem. So -3, this is a good one. Thank you, Delta Math, for giving me a -3. So in here, you definitely want to think about this one this way. -3 times -7x squared plus 6. This guy here is Mario. The whole thing is Mario, including the negative sign. So Mario is going to jump on each term. There's the Koopa one, and then he jumps on the Goomba one. Okay? And that will give us, well, I'm just going to type the answer in here, positive 21 x squared, because -3 times -7 is positive 21, minus 18, because -3 times positive 6 is -18. Hooray, let's go. Next problem. We'll do them all for you. This one will be -18x, because -6 times -3 is -18x. Minus 5 times minus 6 is positive 30x squared. Hooray! Two more. Okay. -2 times all of those, that'll be -8x minus 4x squared. Hooray! Last one. This will be 5 plus 20x. Or I'm going to write 20x plus 5. Okay, I'm going to write my x term first because this is actually standard form to have your variables first and then your constant terms later. And addition, I can do it in any order. Okay, so now that's done. Let's keep going. Exponent rules. Now we're reviewing exponent rules. Okay, this is a review from Unit 1, and this was the part of Unit 1 that we didn't do a very good job with. We had some snow days that compromised our exponent laws knowledge.
You
What'd
made
you notice?
You made a sideways M.
Oh yeah, it's like the Mario here. My daughter has noticed this Mario jumping looks like a M. It's jumping like Mario, right? It creates almost like McDonald's Mario M. Cool. Let's keep going. So exponent rules. In here, we've got d to the 3 times d to the 6. When I'm multiplying exponents, when I'm multiplying powers, I add the exponents. Why, Mr. Jennings? Well, let's take a look. So here, copy it out. D to the 3 times d to the 6. Well, let's expand this with multiplication. If you're ever confused, expand it with multiplication, and it's very clear. D to the 3 is d times d times d. D to the 6, this is multiply, so I bring down multiply. D times d times d times d times d times d. Okay, there's d to the 6. All right, altogether it's d to the 9. D multiplied by itself 9 times. D to the 9. Hooray. Okay. Z times Z to the 3. Well, that's Z to the 4. That's your letter. Okay. R to the 6 to the 2. All right. Now, let's expand this one with multiplication. Not the 6, but the 2. Okay. So I'm going to copy this out. R to the 6. Why are you doing that, Zara? To the 2. Okay. This is equal to r to the 6 multiplied by itself. That's squared. Okay, so that's r to the 6, r to the 6. Now I can say that this is r to the 6 plus 6. This is r to the 12. Hey, where could we get that 12? Here, 6 times 2 is 12. So this is r to the 12.
Hooray.
Hooray. Well, let's keep going. We got some more. And then there's distributed property level 2. Variables and coefficients. Let's do some of these first. Okay. 2x to the 5 multiplied by negative 5x to the 4. Okay. This is not an example of collecting like terms. We're not adding here, we're multiplying. So it's different. We need to use our exponent laws to put these together. So to do a question like this, you're going to write it down.
Daddy,
Yes, Mr. Mouse.
can I come for 1 sec?
Can I cuddle for 1 second?
Come for 1 sec.
Oh, what do you need from me? Here, I'll be right there. Zara, no, I'll do it, Zara. Thank you. Okay, so now remember that you can do this multiplication in any order. It's a big chain of multiplication, and we're going to multiply all of the different ingredients together. So you can definitely find out what 2 times negative 5 is. That's these ones. And then you're going to do x to the 5 multiplied by x to the 4. Uh-oh, Miles is frustrated. So now we're going to say that 2 times negative 5 is negative 10. X to the 5 times x to the 4. Well, we add the exponents, so that's x to the 9. Okay, so that's that one, minus 10x to the 9. Yeah, there you go. That's how you do these. Let's see if we get some new problem types. No, this is the same. So this one will be positive 81, because I square negative 9 and negative 9. X to the 8, because I add the exponents. Good. This one, okay, this is useful to practice. This is a different problem type. So here, copy it out, of course. Well, oh, move over. No, move the whole page. There we go. Okay, negative 5x cubed. Okay, when we're doing this one, if we could write this out, actually, not that bad. Negative 5 times x, negative 5 times x, negative 5x. So notice that the negative 5 is going to multiply itself 3 times. That will be negative 125. And the x will multiply itself 3 times, x to the 3. And there's an odd number of negatives here, so we will have a negative answer. Negative 125, x to the 3. Right. Let's keep going. Okay, so now let's take a look at the distributive property level 2. Here we have to distribute in variables. So let's take a look at it. With this, it really helps to have your exponent laws. So let's take a look. Need some help, Mr. Mouse? Oh, you got your math cards. Want to play with those? We can do some together. Right after this one. After this one, I won't need to introduce the other problem types. The students have heard enough of us for now. Okay, so first thing that we have to do is the brackets, but there's actually nothing to do in there. There's no like terms to collect, so we're done inside the brackets. X squared cannot be combined with an x. But we can use Mario here. Mario is now a negative x squared, and he wants to jump on this term and then on this term. Okay, so let's do that. X squared times negative x squared times x squared. This is going to be negative because there's an odd number of... Mr. Miles, how can I help you? Okay, negative x squared times x squared. We know it's negative because we have an odd number of negative signs. And x squared times x squared is x to the 4. I add the exponents. Yeah, and then doing this one here, negative x squared times negative x is an even number of negatives, so it's positive. Miles, and here I need to remember that this is minus x to the 1. There's a little cheeky 1 there that's hiding. So again, I add the exponents. It's plus x to the 3. Okay, so this will be negative x to the 4 plus x to the 3. Ta-da. Okay, so I hope that gets you started on this. I'm pretty sure we're going to reshoot this video, but if you made it this far, that probably means you're one of the first before I rip the video down and put up a new one. So you can send me the code word, which is smoothie teeth. Okay, bye for now, everyone.
Now, can I my turn?